Alright, today I'll be going over Dijkstra's algorithm starting at vertex 0, and we want to see what order of the vertices were visited before vertex 2 was visited. So, we're starting at 0, and we see that it has two outgoing edges, 4 and 3. The weight to get to 4 is going to be 4, the weight to get to 3 is going to be 1. We're going to go to the node that has the most cost-efficient weight, which is going to be 3 in this case because it has a weight of 1, which is less than 4. So now that we're at node 3, we're going to see it only has one outbound edge, which is to 7. And to get to 7 from 0, it's going to be 2 because 1 plus 1 is 2. And now that 3's outbound edges have been explored, its edges are going to be relaxed, and now 3 is visited. So it's 0 and then 3. Now, all we know so far is that to get to 0 to 7, because 7 is unvisited, it has a weight of 2, and to get to 0 to 4, because 4 is unvisited still, it has a weight of 4. 2 is less than 4, so we're going to pick 7 as the node to visit. So we're at 7. 7 has no outgoing edges, so thus its edges have been relaxed, and we can mark 7 as visited. And so now our list is 0, 3, and 7. And all we know now is that for all the current unvisited nodes, 4 has a weight of 4, and all of the other nodes have a mysterious weight that we'll classify as infinity. And we're going to pick the smaller weight, which in this case is going to be 4. So we go to 4 node next, which has a weight of 4. And we see that 4 has two outgoing bounds, which are 6 and 2. We can see that the distance to get to 2 is going to cost a weight of 5, because to get to 4 costs 4, then 4 to 2 is 1, 4 plus 1 is 5, so we know that it costs 5 to get to 2. And to get to 6, it has a distance of 2 between 4 and 6, so 2 plus 4 is 6, so the cost to get to 6 is going to be 6. And now that 4's edges have been relaxed, we can classify 4 as visited, so the order of vertices visited before 2 is 0, 3, 7, 4, and then 2. The next node to be visited after 2 is going to be 6, because what we know so far is that 6 is unvisited, 1 is unvisited, 5 is unvisited, and between all of those values, the cost to get to 6 is going to be the least because it only costs 6 to get there so far. And the cost to get to 1, what we know so far, is infinity, and the cost to get to 5 so far was 8, and 6 is the least of those. So we're going to go to 6. It has 3 outgoing edges, and we can, to get to 2, it's going to cost 3. To get to 1, it's going to cost 20, and to get to 5, it's going to cost 1. But in reality, since it costs 6 to get to 6, we're going to add that, so 6 plus 3 is 9. 6 plus 20 is 26. 6 plus 1 is 7. And so we see that it costs 7 to get to 5. 5's current route to get to it costed 8. But since 7 is cheaper than 8, we're going to update this to be 7, and its edge is going to be 6 instead of 2.